Okay, morning people. So we have only one more month left until summer, until our maybe around one more month until our final. So I recommend all of you to continue with your homework. Start your assignment number 3 if you already watched the video. Okay. Show me more dedication toward the course, okay, because I'm going to use that your learning behavior to determine your grade. Whether or not I'm be lenient on you will be based on your learning behavior also. Okay. All right. So today is, let's see, what's the date today? Today is March 25th. We're going to continue with our module, concept, our new concept. And I suppose that you already watched the video. You know what two new functions you learned over the past two weeks, which is the exponential function. You're supposed to know that before test number 2, and logarithm function, which is after the second test. The video I showed you last time, you should go to watch that. Okay, I'm sorry I'm late in Canva, so I had to use Outlook. Okay, all right, that's fine. Okay, so those videos you're supposed to watch there already. You know that I kind of overview, the idea what's exponential function is, what logarithmic function is. Okay, and today I will say we continue with our logarithmic function. I will do some example on how to simplify logarithmic expression. Okay, because those hopefully I hope that it will be on the test, but if you're lucky it will be on the third test, because those are very important concepts. You will see that again and again. So I have to say the college algebra concept is very important because it's the foundation of everything. Okay, so let's get started. Any question for me before we started? Good. Just forget about test number 2. Okay, even you did really badly, just ignore it. Okay, don't let it give you stress or anything. That's fine. I mean, if you already, whatever you done, you done. Okay, you did bad, just ignore it. If you did well, did really well, I'm happy for you. But if you did really bad, that's fine. Just focus on the third one. Okay, and everything will be fine. All right, let me share the screen. So this is the screen. Oh. So I'm going to put the topic today will be log expression, simplification. We learn how to simplify log expression. Okay, and in the video I mentioned a bunch of property which is you're supposed to memorize all of them, okay, to be able to simplify log expression. If you don't memorize the property, it would take you a lot of time, because on the test you don't have a cheat sheet. Okay, you have to write them down first, and if you don't memorize, it's very hard, because you have to look at the formula and you look at the question and you see, okay, which formula I should use for each question like this. Okay, so it's good. It's much better if you memorize all the property. So let me recall the properties in the video first. Okay, so you know that log function is something like this: f of x equal to log base b of x. Sorry, I need to change the. This is not good pen right here. Log base b of x, and we know that b is called the base. Okay, and x, everything inside parentheses we call the argument, which is all the x value that make the function define, or we can find the domain of the log function based on whatever inside the parentheses. Okay, and we have the graph of the standard log function. This the standard form is something like this. Okay, this is y, this is x, and when you look at the graph, okay, you know right away that the domain will be from 0 to positive infinity, because you see that we had a vertical asymptote. The graph, the graph right here, this end right here is, oh, it get really close to the y-axis, but it never cross. Okay, it never cross. So it got really close, but it never crossed. That's why we had a vertical asymptote as the y-axis. Okay, and that's the reason why all the x value defined for log function from 0 to infinity, not included 0, because it's not crossing the y-axis. Okay, the range will be very easy. The range will be from negative infinity to positive infinity. Okay, so that is the domain and range, the function of the very standard log equation. Of course, some log equation is very complicated, and it's kind of hard for you to find a domain. Okay, I don't think that there will be some question like finding domain of the log function, because if it added by 2 or divide by something, you have to use transformation to graph it. You have to analyze the domain of that log function based on the transformation. That's one considered as one of the method. So finding domain of log function is not easy to some students. Okay, if you don't master how to find domain of the other basic function like radical function, rational function, then the log function to you will be really hard. Okay, and I hope that it will be on the test. Okay, so that is the graph and the domain and range. And in the video, I also talk about the property. So the property of Ohm log. Okay. The first property is log base b of b equal 1. So the first b over here considered as the base. The argument is also b. So you see the base and the argument in this case is the same. The argument is not x anymore. The argument is also b. So
I have a question.
Yes.
What does that say in the red writing next to log b?
This one?
Yeah.
Property.
Okay.
Property. Property. This is all the property of log. So if you have the base and the argument the same, then it turned out to be 1. Okay. If you have the base b, but the argument is 1, then it turned out to be 0. Okay. Now the second formula you have to memorize. Another formula I want you to know is, so this is the first one, second one, the third one will be log base b of x to the n. Then this is turned out to be n times log base b of x. Okay, so in this formula, the argument is x raised to the n power. Okay. Okay. The base is still b. Okay. Then I can drop down the exponent. I can drop down the exponent to the front and become n times log base b of x. Okay. Number 4. If I have b number and I raise this b number to log base b of x, then this is turned out to be x. Okay, it turned out to be x. So in this case, the b is the exponent. Okay, the same b is also the base. Okay. Oh, I'm sorry. The b over here is not exponent. The b over here is the base of the power number. The whole thing, the log base b of x is the exponent, and b in this case also the base of the log. Okay. Then it turned out you just cancel the b, then it turned out to be x only. Okay. Number 5. I have log base b of x times y. Then it turned out to be log base b of x plus log base b of y. So this formula is called log of the product. Log of a product, because it's log of the product. X and y is multiplication. That's why we call it log of the product. And number 6, we have log of a quotient, because we have log of base b over x over y, then become log base b of x minus log base b of y. This is called log of a quotient. Okay. Number 7. In this number 7 formula, it's good if you memorize it, but I don't think that we have to use that in homework exercise on the test, but it's good if you know. Okay, which is log base b of x is equal to log base c of x over log base c of b. So this formula we call the change base formula. I hope that you don't have to use it. Okay. So there are 7 formulas here, and I want you to memorize it. And I already mentioned in the video. Okay. And another one, actually, I supposed to recall before the property, we call that log principle. The log principle states that if we have y equal log base b of x, then it's equivalent to x equal b to the y. Okay, I'm gonna box it because it's very important. Okay, so basically you just raise the base b over here to the y exponent. Okay, raise it up. The b value, the base value. And sometimes if we have, or not sometimes, like if we have the the base is 10, then you can throw away the base. For example, if I have log base 10 of x, then in the textbook, you see in the my open math, they write it as log x. So if the base is 10, then you can throw away. Then you can throw away the base. You can write it as log x only. So if you see something like this, you know right away that is base 10. Okay. If you don't see the base, it means that base 10. Other than that, all the log must have the base. Okay. All right. Or if we have natural log is base e. Base e. We call it natural log. Then usually they write like this. ln x. Oh, I'm sorry, this is log base e. Okay. So they don't write log ex anymore, but they write ln x. This is called natural log. Okay. Some students ask me like what e number is. Actually, you can see the e number right over here. I can tell you see that if you have a graphing calculator or just scientific calculator, the e number is this. The e number is 2.718 is right here. E number. Okay, you see letter e right here. Okay, so log base e, it means that it log of base 2.718. Okay, and then you see that if you write log base 2.718 to a blah blah blah, it takes too much space, right? It takes too much space, so that's why they just write ln x. Just write ln x. Okay. So if you see in your exercise, if you see in your test, if you see log x, that log base 10. If you see ln x, that log base e. Okay. Any questions so far? Good. So basically, those information you need to grasp before doing homework. And over here, it's just the summary. Actually, there's more information, but I have to say that this is a very key information, important information. You must get it before doing homework. All right, now I'm going to jump to the example part. Okay, in this example, we're gonna use the property of the log, which is this 7 property right here. Okay, to deal with 2 different type of question. Okay, the first type of question, is compress log expression as 1 log. That's the first type of question. The second type of question you might see, it is expand log expression, okay, to 2 or 3 or more log. So one question will be compressed. They give you a bunch of log, and you must compress or condense as 1 log. And the second type of question is they give you 1 log only, and you have to expand them. You make it bigger. Okay, make it bigger. All right. Let's go through the first example right away. You know, we can say like that. It's very hard for you to imagine. So let's take a look at our first example. I'm gonna put the formula right over here, so it's easier for you to see. Oh, it's kind of blurry. There you go. Focus. Okay. Okay, so in the first example, let me see. See which one we should do first. I think we should do expand first. Okay. Example 1. Expand the log. The following log. Have enough space. Okay. Okay. And the question is like this. If I have log base 2 of 15x times x minus 1 inside parenthesis over 3x plus 4, 2 minus x. Okay. What if in the homework you see something like this, or what if in your test you see something like this? So how are we gonna do that? Okay. First of all, I want to remind you this, and I see that so many people get mistakes, so many students. It is that your handwriting must be very clear when you're dealing with log. Why I'm saying so? Because you see that the base, in this case, in our example here, the base is 2. The base is 2. Okay, and that is a subscript. So, and because that's a subscript, when I'm writing the base, I make it really low. You know, I make it really low compared to the log. Okay, because some of you guys write like this. Some of you guys write like this. Not careful. Some of you guys write log base 2. You see that? 15x minus 1 over 3x plus 4, 2 minus. The reason that you guys shouldn't write like this, because you see that the subscript, the base 2 over here, you have almost in the same level with the log. And some of you have this mistake. Some of you later on think that this is logs of 2 times 15x. 2 minus. On the first slide, you think that that's the 2 is the base, but because you don't write it carefully, on the second line you think 2 is just like a part of the argument. Okay, so you have to write carefully when you're dealing with the log. All right. So now get back to the example. So the strategy to deal with this kind of question is that first, you must be able to recognize what part in the question is the argument. Okay. What part is the argument in that log? Okay. What is the argument? We go back to the definition and we'll make a recall over here in the first couple of weeks of the session today, a couple of minutes of the session today. You see that everything inside the parentheses is considered argument. Everything outside is considered as the base. So look at that. So everything inside the parentheses, in this case, must be the bracket, because the bracket is cover the parentheses. So the argument is everything inside here. Okay, you see that it's totally separate from the base number 2. Okay. So you must be able to recognize that first. After you recognize the arguments already, you look at the property. You look at the property. So this is our property. And you make the decision what property you should use. I mean, if you memorize it, I would say if you memorize, then you have the property in your brain right away. But if you can't memorize it, then you have to look the property list and see which property is look like the example. Okay. Now we scan it. We scan. Let's scan from the top. Let's scan from the top. It's our first property right here. Our first property said that the base and the argument the same. Oh, it's not, right? Because over here the argument is this and the base is 2. It's not. Property 2? No. Property 3? No. Because we don't have exponent. Property 4, it look like? No. No. Property 5? Maybe, right? Because you see on property 5, we have the product, and you see we have the product here. We have a lot of product. We have a lot of product. Okay, we have 3 product right here. Property 6. Yes, because we have fraction. You see the argument is the fraction. And now we look at our argument. Oh, it is a fraction because we see the big bar right here. We have a numerator, we have denominator. It means what? It means that we must use property 6 and property 5 to do this. All right. So now let me use property 6 first because this is a fraction. All right. So in our property 6, you see that if we have a fraction, we can expand it to a difference. See, fraction, we can expand it to difference, to a difference. Same thing over here. So I'm going to expand it. So I'm going to put log base 2. Okay. Log base 2 of the top. See, the top in this case is x. Okay. So it means what? It means the top in this case would be 15x times x minus 1. You see that? You see the argument when I'm writing, the argument is on the same level with the log. The base is lower. Okay, because the base is subscript, write it lower. Okay, minus log of the denominator. So log base 2 of the denominator. Denominator is this. So 3x plus 4 times 2 minus. Okay, everybody got me on the first step. If you don't get it, let me know right away.
I got you.
All right. Okay. No, but we haven't stopped yet. We have to keep going because this is not fully expanded yet. All right. Now, because now we have 2 log already. And the log right over here, we have to rescan it. And we see, it looks like it's a product, right? It's a product because there's a product right here. There's a product right here. Okay. Then a product give you the sum. The product give you the sum. So I can write this as log base 2 of 15. That's the first factor of the product plus log base 2 of x. That's the second factor of the product plus log base 2 of x minus 1. You see that? Because we have 3 factors. Because we have 3 factors. The first factor is 15. The second factor is x. And the third factor is x minus 1. Then we can split them up into 3 log using addition sign. Okay. All right. Now let's take a look at this log. We're going to do the same thing. But you have to be careful because in front of the log over here is minus. In front of the log over there is minus. So I'm going to put minus and open bracket. Okay. How many product we have in the second log? How many factor we have in the second log? Anyone can tell me how many factor right here? How many factor? This is
3.
separate. Actually, there are only 2 because you see, this is separate by only 1 multiplication sign. So the first factor is this. The second factor is this.
Okay, I wasn't sure if we would like separate the 3x. Okay, I got it now. Okay. Because the multiplication side tell you exactly how many factor you have. So you have 2 factor. It means that you can split into 2 log. So they become log base 2 of the first factor. Okay, plus, right? Because factor product give you addition, product give you addition according to the formula, plus log base 2 of 2 minus x. Okay. Now we're going to distribute the minus into the bracket. So let me rewrite it: log base 2 of 15, log base 2 of x, log base 2 of x minus 1, minus log base 2 of 3x plus 4, minus log base 2 of 2 minus x. Okay. Now, we have to ask ourselves that we should stop over here or we have to continue. That question is kind of like, I mean, it's for everything, right? That type of question, because a lot of students don't know like when we should stop. All right. So we look at the log and you see that the first log, we cannot do anything. The second log, we cannot do anything. The third log, all right, we scan it. We scan all the property here.
Quick question.
Oh, yeah.
So all you did on that part was put that negative into the brackets?
Yeah, I just distributed.
Okay.
Yeah, I just distributed.
Thank you.
Exactly. Mm-hmm. The third log right here, we have a log of the difference. Okay, let's take a look at the formula right here. Do we have anything, something like that? Do you have like any property that's look like log of something minus something? No, we don't have it. We don't have that type of property. We have log minus each other, two log, but we don't have log of something minus something inside parentheses. It means what? It means we cannot do anything. It means that every time you see something like this, we cannot do anything. Can't. Similarly, we can't do anything over here. We don't have log of the sum. We have log of the product. We have log of the quotient. We don't have log of the sum. We don't have log of the difference. Okay. It means that we can stop here. That's it. So I just successfully expand one log. The original question has only one log into the final answer that contains how many log here? 1, 2, 3, 4, 5. So everybody can see that. Okay, I successfully expanding one log into 5 log. Okay, and I can't expand anymore because I look at the property, I don't see anything else that I can expand. All right, everybody clear on this? You see that I take a lot of time because I want to go really slowly. Okay, and I take like almost 15 minutes for the first example already.
I think I need a couple more examples.
Exactly. But I mean, that's what I see. I don't have enough time for you guys. See that? So you must watch the video. In the video, in the module video, I give you more examples there. Okay. So that is for expansion. Let me see. I can have another example for expansion or not. I think I do. All right. How about something like this? Math is very transformative, guys. It's the concept is the same, but the problem is not. The problem itself is not. And that's why you cannot do math by routine. You don't do math by routine. You do math by logic. All right. Let's take a look at this one. Let's use log base 10, okay? Because log base 10, we don't have to write 10, so I just write log. And I have something like this. Log base 10 of a fraction. You see, that's good, right? Because we know right away we had a fraction, which is that is the first property we should start with. Square root of x time time x minus 1 raised to the third power over x squared y4. Okay, let's make it simple that way. Again, the question is expand the log.
Wait, there's no base.
Base 10, we don't need to write a base.
All right.
Yeah, base 10 is right here. Base 10, we don't need to write a base. But nobody write base 10. Okay, they just write log without number 10. So I'm using base 10. All right. All right, so how are we gonna do this? Again, you scan the property and you stop at the fraction, which is property number 6. And because this is a fraction, I can split it up into 2 log. Log of numerator and that's the log of numerator. You see that the argument and the log, I'm kind of writing on the same level. I'm always right on the same level. Okay, minus, right? Because according to the property, see that log of the top minus log of the bottom minus log base 10 of x squared y4. All right, so after you split in the log into 2 log, you're asking yourself, can I split more? Yes. Okay, now you look at the first log right here. We have 2 factors separate by multiplication sign. There's only one multiplication sign right there. It's the only one. Okay, then I can use the formula number 5. You see that? Product give you the sum. So the first log I can split into log square root of I plus log x minus 1 raised to the third power. Okay. Now let's deal with the second log. Same thing. How many factor? How many multiplication sign? So you have only one multiplication sign right here. It means that you have 2 factor. Then you can split it up using the same property. So it becomes log base 10 of x squared plus log base 10 of y4. Any question for me so far?
I'm just assuming that the 10 is invisible, right? It's still there,
Exactly.
but
Yeah, it's invisible. It's still there, but it's invisible. Invisible. Have you guys watched the Invisible movie? Have you guys watched that movie? Oh, that movie is really good, guys. You guys should watch it. You guys should watch it. It's a good movie. You know, after I do math like that, I always watch a movie. One movie per day. A movie addict. Okay. So after you split it up, okay, and you ask yourself if you can split more, but before doing that, let me distribute the minus sign. Invisible. All right, so let me distribute the minus sign. So I already distributed, okay? Now, all right. Now, the question is, if we can stop here or we continue. You see over here on the first log, let's deal with one by one. Let's look at the first log right here. Right now we have 4 log already, which is really good. I mean, from 1 log, I split it up into 4 log. It looked like we got it done. Look like. But you have to be careful, because the first log right here, let's take a look at each of the log right here. Our first log is a log of radical x. And I don't know if you guys remember, every time we have radical, we can convert it into rational exponent. So in this case, radicals, I'm gonna write on the side right here. Okay, this is considered as a scratch paper. So radical x right here, I can rewrite it as x raised to the 1/2. Anyone remember that concept you learned in intermediate algebra?
I remember coming over it when I was working on my assignment too.
So right here, radical 2, it means that's invisible 2 right here. So I can rewrite it 1 over here over the invisible number 2. So actually this comes from the formula m root of x to the n is x to the n over n. Okay, intermediate algebra. Okay, so this is invisible 2. This is invisible 1. So they become 1/2. So in this case, I can write the log as log base x of 1/2. Log base x raised to the 1/2, raised to the half power. Okay, now this one, I just rewrite it. Right. So the first log, we have exponent as a half. The second log, we have exponent 3. The third log, we have exponent 2. And the fourth log right here, we have exponent 4. So let me circle the exponent. And the only formula that contains exponent in this form is the third formula. See that? Third form. Argument and the exponent. Actually, the whole thing as argument, but inside the argument we have exponent. So we have exponent here. It means that we can drop the exponent to the front. So the exponent over here is half. Exponent here is half. So I can drop it to the front. So become 1/2 times log base x. I can drop 3 to the front. 3 log base x minus 1 minus 2 log x minus 4 log y. Everybody can see it. Okay. Now we can start.
I have a
Because
question.
Yes.
So you apply the first
The third one.
property to all logs in the third one you just used to all
Yes.
the okay.
All the log. Yes. Yes. To all the log here. So this is third property. Okay. This is the second step right here. I'm using sixth property. Okay. And the third step right here, second step right here, I use 7. Oh no, 5 property. Fifth one. Okay. So it's very important that you should know what property you should use, right? You must know. If you don't know what property you should use, then oh, that will be a hard job. Very bad. You will be in trouble. Okay.
Excuse me.
Yes.
If you don't mind, can you go over which properties we did for the first example real quick?
Okay. So you have a portion, give you the difference. So give you, this is the sixth property. And this is the fifth one. Okay, so this is the fifth one for each of them, for each log here. Okay, so you have to apply the fifth property over here twice. Same thing over here, you have to apply it twice. Okay, and but for the first example, it's simpler because you don't have to use the third property. See, you stop right here already. You don't have any exponent. You see that? You don't have any exponent. You have the argument only. Okay, but over here, because you have the exponent, exponent, so that's why you have to apply the third property. So example number 2 is more complicated than example number 1 because you have to apply 3 property. Example number 1, you just need applying 2 property. Okay. Any concern for me? Good, good, very good. All right, now example number 4. In example number 4, we're going to deal with the second type of question, which is compression. So in this example, they give you a bunch of log, and they ask you to compress. Some of the textbook they write condense. Okay, but I can try compress log expression. Oh man. Okay. I don't know why. Sometimes this works and sometimes this pen is not working. Okay. All right. Let's take a look at this example. Let's see. Okay. How about this one? This one looks really cool right here. I have something like it. I have log base 2 of x squared, okay, plus 1/2 log base 2 of x minus. So you see that when I'm writing really carefully. You see the base, I do the subscript and then really drop it down. Okay, minus 3 log base 2 of x plus 3 raised to the second power. I hope that I have enough time to do only one example for compress. Then maybe next time I'm doing one more. Okay. So this is our question. And you see that we have 3 log. We have 3 log. Okay. And the good thing is that all 3 log over here has the same base. At the same base. It's the base. We have the same base. If we have different base, oh, we'll be in big trouble. Okay. If we have a different base, then you have to use the property 7. Change base formula. And I hope that you don't see different base in my open math. Okay. I hope so. So they must give you the same base in general. They probably give you different base if they want to. But it's much easier if you have the same base. It's much harder if you have different base. All right. Now we have 3 log. Our job is to combine it as one. As one. All right. It means what? It means that we kind of go backward. If you look at our property for expansion, we go from left to right of each property. But now for compression, we go from right to left. We go backward. Okay, we're going backward. Okay. All right. Now we see that over here we have the sum of 2 log, and the only formula we have the sum of 2 log is number 5. See, I'm gonna go backward, so I'm gonna combine 2 log into 1 log. So you see that I'm going backward. Okay, now 2 log, I have 2 log. I'm going to combine to 1 log. Okay. However, before doing that, I look at the second log right here. I see the problem that in front of the log we have number 1/2. Because in order to combine, you see that according to the property, in front of the log there's nothing. Actually, invisible 1, but there's nothing.
It would be 3, no?
Would it be 3? You mean, what do you mean? Would it be 3?
Like the third example or the property?
Yes, very good. So he said that he's gonna use property 3 to bring the number in front of the log as the exponent. Yes. So we're going to use property 3. So we're going to use property 3 for this second log only because the first log is good already. You see the first log, you see there's nothing in front of the log here. So the first log is good. I'm going to just go ahead and write them down. Okay, I'm going to just go ahead and write them down. Now I'm going to use the third property so I can bring it up as the exponent here, 1/2. You see that I write 1/2 as the exponent. I'm going to write really small, 1/2. Okay. Okay. Same thing over here. You see that? You see over here, number 3 over here, number 3 right here. We shouldn't have number 3 here, so I'm going to bring it up. So it becomes log base 2 of x plus 3 square. Square is belong to the original, okay? Raise everything to the third power. All right, so I'm gonna put the property right here using third property. Backward. Okay, I'm gonna put backward because you have to go backward. Okay, now it looked like that in front of the log there's nothing already, which means that we can combine. I can combine two log. See that? The only way I can combine two log is using number 5. Because we have two log, I can combine it as the product. So I can write it as log base 2. See that? Because of the same base, then you can write it like that. Of, you have to open bracket because you already have parentheses. So you have x squared, see, the first argument times the second argument okay. Okay. Everybody see that or not? This one, I'm not touching that. I'm going to just go ahead and rewrite. So I'm going to just go ahead and rewrite it. I don't want to touch it right now. You can touch it, but I mean, I don't want to. Because some students good, some is not. So I just leave it for the time being. So everybody get me over here. So this is fifth property. Backward. Right there. Ask me right away if you don't get it, okay? All right. Now, you see that? Originally, we have 3 log. Now what? We have only 2. But again, you have to ask yourself, can we combine more? Yes, because you have 2 log and the difference between 2 log is minus. Now I'm going to look at the 6th property. You have 2 log and between the log is minus. So I can write it as a fraction. All right, so how am I going to write it as a fraction? So that it become log 2 fraction, see, of the top, okay, of the top over the bottom. Okay, everybody can see that. All right, so this is 6th property backward. Oh, now what? Originally, we have 3 log, but now we have only 1 log. Oh, we're done. Actually, we are already done because we already combined 3 log into 1 log. But again, you know, I don't know if you guys remember on the first day, I said it to you on the syllabus day, I said to you, math is beauty. So we have to beautify it. Because if you put this into my open math, they probably don't take it. They might not take it. Even though you get them right. Because you already compress it. You already combine 3 log into 1 log. But it's not a perfect answer yet. It's not. It's not a beautiful answer. All right. So we need to do one more step. We need to do one more step. Let me, I don't have enough space right now, so I'm gonna just write it. Oh, sorry. Just write it somewhere over here. Okay. All right. So this has become equal log base 2. I'm going to beautify it. Okay, log base 2 over x squared. I cannot do anything. But remember, when you have rational exponent, I can rewrite it as radical. Okay, the formula I just give you over here. Right here. This formula. Going backward. You have exponent, I write it as radical. Okay. Okay. This one, I can write it as x plus 3 raised to the 6. Anyone remember how I can do that?
You multiply the exponents.
You multiply the exponent because the formula x to the n raised to the n equal x to the n times n. And now this is our final answer and we're done. This is beautiful answer. Any concern, any question for me? So is it easy or not? I mean, that
This is not easy.
question,
Yeah, it's easy.
that question you have to answer for yourself. If you memorize all the formula, if you practice a lot of problem, that will be easy.
I feel like it's just expanding and shortening stuff, you know. So you just gotta
Exactly.
look at
But if you don't memorize the formula, it's hard because every time you look at the formula, well, you can look at the formula, you can look at the property, and you just start scanning. You start scanning, okay, which one I should use. But you have to do a lot of problem to see which one you should do first. Right? Because if you do sometime you apply one formula before the other one, then it will give you it will take you less time. Okay, if you apply the wrong one right at the beginning, then maybe if at the end you may get the final answer, but it might take you a very long time because you just go around and around and around. Okay, so your job after you already got it, and I assume that you already got it because nobody asked me right now. After you get it, you have to do a lot of problems. Okay. Any other concern? So I think that's it for today. I'm gonna just go ahead and take attendance. So next time on Tuesday, go ahead, continue with your homework. Okay, do not fall behind, and go ahead and start your part B of the assignment right now. I say right now, okay, as soon as possible. Then on Tuesday next week, we're gonna do another concept. We learn how to solve rational. We learn how to solve exponential and log equation. That concept is also harder than this one. Okay, so you see, but toward the end of the semester, the concept is much harder. It means the test is harder. It's harder for you to make it up for the second test. However, again, if you make it up for the second test, if someone had a really low grade on the second test, then don't worry too much. Then you just remind me. I might use the third test to replace for your second test. Okay. I already say so. So that's it for today. Okay. On Tuesday, we're gonna continue with our next concept in the syllabus. All right. So I'm gonna stop sharing the screen. I'm gonna take attendance, and when we take attendance again, if you have any other concern, let me know. Let's see. So look in here. Jasmine, you there?
Here.
Okay. Elisa?
Here.
Okay. You can log out if if I already call your name, but again, if you have any question, let me know. Max, you here, Max? Max? All right.
No, sorry, I'm here. My mic.
Oh, you
was-
okay. And Natalie?
Here.
Emma?
Here.
All right. Alberto?
Here.
All right. And Nadia?
Here.
Okay. Tajana?
Here.
Lauren?
Here.
All right. Have you guys a good day. Bye-bye.